All right, class, everybody get your safety glasses out and your lab coats on. It's time for a science demo. Let me just put everything on the counter. All right, class, can anyone tell me what this is?
Gatorade.
Gatorade. Okay, I brought it in a Gatorade bottle. It's not Gatorade. Any ideas? We were just talking about universal indicators.
Oh, is it a universal indicator?
Exactly, Malcolm. So this isn't universal indicator. It's called anthocyanin. Who's heard of that term before?
Sounds like cyanide.
It might be related to that. We can talk about that later. So this is anthocyanin. It is the coloring agent that makes red cabbage purple. I boiled some water, and I boiled red cabbage in water for about 20 minutes yesterday to extract it and put it into this Gatorade bottle. You can drink it. I don't suggest doing so. It tastes terrible. All right. I've also brought some household things from around my kitchen. So, this blue one here, can everyone see it all right?
Yep.
And then here I would pass it around. Who wants to tell me what this is?
Soap.
Soap. Awesome. What happens, what do you think would happen, talk about it with the neighbor, if I poured some of this solution into the soap?
It would get bubbly.
I think it'll turn colors and stuff.
Yeah.
Right? Right?
Yeah, that sounds right to me.
Yeah.
Yeah.
I don't know if it's an acid.
I don't
You know,
remember which one.
they use like acids and stuff, right?
Soap is
Yeah.
base.
Yeah.
Soap is, yeah. Soap's like, gotta be a base. It's not an acid, right?
Yeah, well, it doesn't burn you at all. You can touch it.
Yeah.
Yeah, it doesn't dissolve anything.
Yeah.
All right, Malcolm, I heard some good conversation from you. What do you think, what did you think would happen when we poured the anthocyanin into the soap?
It's gonna change colors.
Change colors, okay. Why is it going to change colors?
Because soap is not an acid?
Soap is probably not an acid. All right. And how do you know it's not an acid?
Because it doesn't burn me when I put it on my hands.
Well, does lemon juice burn you when you put it on your hands?
Oh no, I guess not.
That's a good idea. So you might want to take a look at your pH tables, which I gave you earlier today, and we can clearly see, that soap is a base. So I'm going to pour some in and mix it a little bit. I'm going to come around and show everybody. I want you to think about what you see and be prepared to share. All right, so what happened when we poured the anthocyanin in the soap? What happened to the color?
Kind of
Tie.
stayed the same.
Oh, awesome.
Yeah, it's almost the same.
Almost the same. Let me pour a little bit on top of this lid here. Or I would have another cup. Well, it actually wound up turning a little bit green and a little bit more blue rather than nice dark purple. Alright, so we saw it change in color. Now I want to ask you again, is this an acid or a base? Or is it just neutral?
Base.
Base. Why do you say base?
Because it's turquoisey blue.
Awesome. So we're saying that for our prediction or our observation is that in a base, anthocyanin turns blue. In a base, anthocyanin, which you don't need to know this word, but it's anthocyanin, turns blue. All right. I have another substance I brought from around my house, and I'm going to bring it around, waft a sniff, we want to be safe, And note the color, and I want you to tell me what you think it is afterwards. All right, Allison, what do you think?
I think it's vinegar.
You think it's vinegar. Why do you think it's vinegar?
It smells like vinegar.
Yeah, vinegar has a very distinct smell. So other liquid is vinegar. Now, if I pour the vinegar, or if I pour some of this in the vinegar, what do you think will happen?
Turn red.
It'll turn red. Why do you think it'll turn red?
Red's an acid. Or vinegar's an acid.
Vinegar's an acid. How did you know that?
It's sour when you drink it?
Exactly. If you remember from yesterday, we talked about sourness when you drink acids. I'm going to pour some in and mix it around.
Oh.
So, I don't think I need to carry this around to show you the distinct color. It's a nice, bright pink. So we said it would change color. Can someone tell me the difference between the two colors and why they might be? They both changed color, but they changed to different colors. Malcolm.
Because one's an acid and one's a base.
Yes, one is an acid and one is a base. So I'm going to erase here and put base. All right, we have two more ingredients to get through. I'm going to bring this one around. Again, waft and take a sniff. And let me know what you think it is. All right, Bree, what do you think this liquid is?
Didn't get a great smell.
You didn't get a great smell. All right. If you can't tell, here I would probably put lemony perfume in before to make it extremely obvious. It's lemon juice.
Oh, okay.
I went and I got some squeezed lemon juice and put it in here. What do you think will happen again if I pour some of this liquid into it?
Brighter red.
Brighter red. All right. Why do you think brighter red?
Because lemon is very acidic.
Lemon is very acidic, so we're going to find out.
According to the table in front of us.
Yes.
According to this table, yeah.
So here are our two liquids. I'll bring them around to give you a closer look. And I want you to tell me what you notice between the difference in color. If it was...
Oh.
So did our experiment confirm our observation that we would have a brighter red?
No.
Malcolm, why don't you come up here and look at them from above? It might help you get a better
Oh, okay.
idea.
All right, Mr. Roberts.
All right, so which one of these here is more red?
Oh, well, you said lighter, so I thought that's a darker red.
I meant, darker, okay.
Yeah,
I meant
yeah.
more vivid.
Oh, okay, yeah, that one there.
All right, so for our lemon juice, we said change color, also it was an acid, and we said more red. Because it was more acidic. All right, and the final one. This time, I just want you to take a look at what I've put in the container here.
Mm-hmm.
All right, does everyone see what I've put in here? A white powder? I want you to talk about what that might be.
Sugar, can we taste it?
You can taste it, and I would pass out some tasting samples.
Oh.
And I would have all the paperwork to make sure that I was safe and I was allowed to.
Okay.
And it's not sugar. You taste it and it's not sugar. Well, these are all baking ingredients. It might be salt, but you would have tasted
flour.
it.
Baking soda.
It's baking soda. It would be obvious from how bad it tastes. Yes, this is baking soda. Now, is baking soda an acid or a base? Is it neither? It's not a liquid. All the other things we've been working with and talking about have been liquids, but what about this one?
Maybe it's in the middle somewhere.
Maybe it's in the middle. All right. So if we go back to our pH scale, what was in the middle? Which pH number?
7.
7. And we described that with the word, starts with an N?
Neutral.
Neutral. All right. So we're going to say baking soda is neutral. All right. So when I mixed the indicator with water, which is essentially this, it was purple. So when I pour my solution into the baking soda, if it's neutral, should it change color or should it stay the same?
It should be green, like the pH scale in front of me that says neutral is green.
Ah, well, we'll check that out. We'll see what happens. All right, so I've mixed it around. And I'll now bring this so everybody can see it. And I probably shouldn't have brought a blue container.
Oh.
So we see we get a nice dark blue, which is different from the purple of our water. So did it turn green like we thought it might?
No.
No, it turned blue. So is that pH scale entirely perfect for colors?
No.
No. And comparing it to this one, would you say baking soda is an acid or a base?
Base.
Base. Now, everything we've talked about for bases and acids have been liquid so far. Is this actually a base?
Yeah, because it's
Yeah.
a liquid now.
Yeah, it's a liquid now. What did we do with it? What did we dissolve it in?
Universal indicator.
Yeah, and what is one of the components of our indicator?
Cabbage.
And what's the other component?
Oh, water.
Water, yeah, we dissolved it in water and then also the indicator at the same time. So we're able to take it from a solid to a liquid to figure it out. Now, I have one more thing to show you before we're done for the today class. What do you think will happen when I mix the vinegar solution and the baking soda solution?
It'll be neutral.
It'll be neutral. Think back to earlier. What happened in elementary school when you mixed these two?
It'll fizz up.
It'll fizz up. And I want you to think about what that fizzing might be indicative of.
Ooh.
So, what did we just observe between the baking soda and the vinegar?
Chemical reaction.
We saw a chemical reaction. So when we mixed the vinegar, which we said was an acid, and baking soda, which we said was a base, we got a reaction. So there was some reaction, we got products. What do you notice about the color of our solution now?
Purple.
Yep. And what do you think the pH we have for a purple solution is?
10 high.
This was neutral, remember?
Oh,
Neutral.
7.
Oh.
7. So we said it, one of our products, one of which was neutral. And what is a neutral substance? What's one of them? The big one we talk about? We would
Water.
have done this yesterday. Yeah,
Distilled water.
Water. And there's something in the bottom. This is a bad example. I should have used more stuff. So actually, class, I'm going to call it here. We would go lead into our talk on neutralization. After this, we would figure out that there would be some residue left by straining the water overnight, and we talk about that and how there's salt. And this would all lead into an activity where they're going to use a universal indicator to come up with a colored pH scale and investigate water quality around the school.